All right, for today's lesson, we're going to be talking about systems of inequalities. So you've talked about one inequality where that shows the system where it's shaded. Now we're going to talk about a system that is composed of two inequalities, and the solution region is where the graph overlaps. So if I'm looking at this graph down below, I can see that there's two graphs that are shaded here. So I have the dashed line right here and the shading going up, that's in red, okay? Then I have my solid line and shading going down, that's in blue. Well, those two graphs are going to overlap each other, and they overlap in this area right here. Now, that overlap, and I'm actually going to get the purple because it kind of looks like a little purple color. So this overlap right here is where the solution is. So why is this the solution versus all of the shading? So if I pick a point in just the red area, that point is only going to work for that particular inequality. It's not going to work for the blue inequality. Likewise, if I pick a point that's just in the blue area, that solution point is not going to work for the red. So it has to be in the overlap in order to work for both of them. Okay, so your overlap is where inequality works for both shaded regions. Now, the other thing that I want you to think about is the difference between a dash and a dotted line. Okay, so when I look at a dash line, remember dash lines do not include solutions because dash lines, they can actually, like my reference is if you plot a point, that point can fall through the dashed line. So if it can fall through as an analogy, then that means that it's not a solution. So when I look at a solid line, okay, a solid line, the point can sit on that line. So it isn't a solution. So when I'm looking at this particular solution again, I'm going to make a list of points that are solutions and then points that are not solutions. So we're going to look at points that are solutions and points that are not solutions, and I'm going to discuss why they're not. All right, so I'm just going to randomly pick a point here, and I'm going to pick some points and some colors that'll show up hopefully pretty well. All right, so my first point that is a solution is going to be 6, 5. So 6, 5 is a solution. 6, 5 falls in the overlap. All right, so a point that is not a solution would be 4, 8. So very close to each other, but 4, 8 is only in the red area. It's not in the overlap. All right, so another point that is not a solution. All right, so we're going to go with 3, 1. 3, 1 is not a solution. Now, I'm doing this for reference purposes. It kind of, if you look at it, it's kind of off a little bit, but we're going to pretend that it's at 3, 1. I'm hoping that that's where it's at, okay? So 3, 1. Why is 3, 1 not a solution? So 3, 1 is not a solution. That's probably one of the most common points that students get incorrect as a solution. Now, the reason it's not a solution is because it's right at the tip of the overlap right here. Okay, now if this line was a solid line, then it would be a solution because two solid lines intersecting each other are solutions. But we don't have two solid lines. This line right here is a dash line. So it would work for the blue shaded inequality, but it would not work for the red shaded inequality. So if you have any dash lines at all, it will not work. All right, so another solution, we have 2, 0. All right, another solution we have is going to be 9 and -3. Ones that won't work, -2, -7. I have 0, -8. All right, so again, if you notice where all of my orange ones are that are solutions, These are all in the overlapped area. Okay, I could plot any point in the overlap and it'll work. So now what we're going to do is we're going to prove that that works. So I have a system of inequalities right here, over here to the side, okay? And I want you to tell me out of these 4 points, which one are solutions. So we're going to start by doing this algebraically. So what do I mean by algebraically? Algebraically means that I'm going to plug in my values to my system of inequalities and see if they work. All right, so I'm going to do this, and I'm going to do it for each answer choice, and we're going to plug in those values. All right, so for the first one, I have an x value of -2 and a y value of 3. So where my x is, I'm going to plug in -3. And where my y is, I'm going to plug in, I'm going to make that correction there. Let me go back and redo that. And my x is, I'm going to plug in -2, not -3. And where my y is, I'm going to plug in +3. Now, does this work for this system? So the question is can it work for one and not work for the other? Yes, that can happen. I can have a point that works for one inequality and not work for another inequality, but that is not a solution to the whole system. Remember, it has to be in the overlap area. If I pick a point that does work in the red region but doesn't work in the blue region, that doesn't mean that it works for the whole system, because the whole system is in this overlap area. All right, so I've got to test them, and I've got to test them for both equations. So now for the y, we're going to put in 3. And for my x, I'm going to put in -2. All right, so now we're going to see if it holds true. So we have -2 plus 6 is less than or equal to 4. Well, -2 plus 6 is 4. And I have that 4 is less than or equal to 4. That is a true statement because it's equal to. All right, for the next one, I have -3 is greater than or equal to +6 minus 3. Well, +6 minus 3, 3 is greater than or equal to 3. That is also a true statement. So let's look at it in Desmos, because we can graph these in Desmos, and I want you to graph them in Desmos. The only time that you wouldn't be able to graph them in Desmos is if they were calculator inactive. All right, so x plus 2y is less than or equal to 4. And you can see that it graphs that inequality for us. Then we have y is greater than or equal to -3x minus 3. Now, the point that we were testing was -2, 3. And that's that point right here. You can see that I just talked about that point at the top of that overlap. So my overlap is in the purple area right here, okay? And that purple area, why is that point working? Why is -2, 3 working? Well, because they're both solid lines. If they weren't both solid lines, then one line would not work. So we now know that -2, 3 is a solution point. Now we're going to do the same thing for 1, 0. So I'm going to go back and I'm going to erase 1 or -2, and I'm going to put 1s. So everywhere I have a -2 in both equations, I'm going to put 1. And where I have +3, I'm now going to put 0. All right, so all I did was replace those, and let's go back and change. Sorry. Let's go back and just erase what we have here. And you can just rewrite it on your paper. I'm just doing it and rewriting it so that you can see that it's the same process over and over. All right, so for this one, I have 2 times 0, that's 0. So 1 is less than or equal to 4. That is a true statement. All right, so for the next one, 0 is greater than or equal to -3 minus 3. So 0 is greater than or equal to -6. That is also a true statement. So if I look at the next point and I put in 1, 0, we can see that that is in the shaded region. So because it is in the shaded region, that's also going to be a solution. That does work. All right, and again, you can rewrite them. I'll rewrite them just like the next one. So the next one's going to be 2 plus 2 times, now this time I'll be doing 4. And that is going to be less than or equal to 4. Then we have 4 is greater than or equal to -3 times 2 minus 3. So we're going to test both of these. Do both of them work? So this is going to be 2 plus 8 is less than 4. So is 10 less than 4? That is a false statement. That is not true. Just by that false statement alone, we should now know that this doesn't work for the system because it's not going to work for both of them. But I'm going to check both of them. And then I have 4 is greater than -6 minus 3. So 4 is greater than or equal to -9. Now that is a true statement. But in order for it to work for the entire system of inequalities, it has to work for both. So it works for that blue area, but it does not work for the red area. So that is not a solution to my system. All right. And I'm going to make this a little bit smaller, so we have a little bit more room. All right, so we did this one. So now let's do one more. So we're doing 3 and -1. So we're going to do 3 plus 2 times -1. And that's supposed to be less than or equal to 4. Then we're going to do -1 is greater than or equal to -3 times 3 minus 3. All right, so for the first one, we have 3 minus 2 is less than or equal to 4. So 1 is less than or equal to 4. That is a true statement. Then we have -1 is greater than or equal to, and then we have -9 minus 3. So -1 is greater than -12. That's also a true statement. So if I graph this point, I should be able to see that it falls in the overlapped area. And again, I can see that it falls in it. So 3 of those solutions that we tested are, or 3 of those points that we tested are a solution to the system. And we learned that we can have points that work for one inequality, but not for both inequalities. It has to be in the overlap, and the overlap is going to work for both. Okay? All right, so this one just says, what type of inequality, where is the solution region? So if we graph this in Desmos, we should be able to see that this inequality, so we have some shading above the first line. All right, and then for the second one, we have shading below. So if we look at the overlap is going to be in that top area. So the answer choice here that is actually going to work is going to be this one, okay? Because the overlap that we see in the picture is the top part. We have green, we have blue, and actually I can change it to red if you want so you can see a little bit better. So we have that overlap between the two. Next problem, we have, so they've graphed the lines for us. So they gave us the equations, the initial equations. So that's where these equations up here come from. They graphed those equations for us already. Now what they're saying is if I turn these into inequalities, which region is going to be my solution to my inequality, my system of inequalities? So if I graph these, I should see that the overlap is in the top part. So that top overlap is up here. And that means that my solution region is going to be region number 1. All right, so again, we could test these algebraically. That should be no issue at this point after we did the last one. But let's look at it graphically as well. Let's look and see which points are going to fall in our solution area. So we're going to put these in Desmos, and we're going to look, and we see that the solution area is on the right-hand side. So I'm going to plot my point. So I have -310, and I can see that -310 works in the blue area, but it doesn't work in the red. So it's not in the overlap. So we can go ahead and cross out A. All right, so then we're going to do -1, -5, +5, excuse me. We can see that it's on the dashed line, so it actually is not going to work for the red or the blue, and it's not in the dashed area, so we're going to get rid of that answer choice. And then we have -1, 2 for our next coordinate. We can see that that's not even in a shaded, so it's not going to work. And then finally we have 5, -2, and 5, -2 is in the overlap, so the answer here is D. And you could also plug them in and see if it works algebraically. All right, and then the last one, again, I have my system of equations. I can see that we have y is greater than or equal to -2x plus 2. And then I have y is less than or equal to 2x plus 2. And we see that the overlap is on the right-hand side. So we're going to do -1, -2. That works for the green area, or the light green, but it's not going to work for both of them. So that's not going to be the correct answer. So then we have 0, 0. So 0, 0 again is in the light green area. It's not in the overlap. And then we have 0, 4. 0, 4 is now working for the blue area, but that's not in the overlap. So the only one that is left is 2, -1. And we can see that that is in the overlap. So let's look at a couple of examples algebraically. Let's say we're testing number 1. So number 1, we're testing the point -1, -2. Okay, so let's label X in yellow and Y in pink. So if I take my inequality and I'm going to plug in for y is greater than or equal to -2x plus 2, and then I also have y is less than or equal to 2x plus 2. All right, so for the y piece, I'm going to plug in -2 is greater than or equal to -2 times, and then my x piece is -1 plus 2. All right, so we have -2 is greater than or equal to +2 plus 2. So -2 is not greater than or equal to 4. That right there, making it a false statement, means it's not going to work for the inequality. Even if I plugged into the second one and it does work, it does not work for the entire system. So if I plug this in, -2 is going to be less than or equal to 2 times -1 plus 2. All right, so -2 is less than or equal to -2 plus 2. Well, -2 is less than or equal to 0. That is a true statement. So it worked for one inequality, but it doesn't work for the system of inequalities. It doesn't work for both of them, okay? So the only reason, let's check our actual answer choice. So I'm going to go in and I'm going to replace my values that I just plugged in with the correct answer values. So we're going to try out 2 and -1 this time, and it's going to work for both of them. So we have X and we have Y. All right, so my Y's are going to become -1, and my X's are going to become +2. All right, so we have -1 is greater than or equal to -4 plus 2. So -1 is greater than -2. That is a true statement. Then we have -1 is less than or equal to 4 plus 2. So -1 is less than or equal to 6. That is also a true statement. All right, so that's how we know it works, because it works for both of them. So a system of inequalities, if you do it algebraically, when you plug your values in, your coordinate value, then it has to be true for both statements. If you look at it graphically, you're looking at the overlap. That's the only place that the point is going to work for both.